Okay, welcome to the talk. I guess you all had lunch and probably some coffee too, so I'll try to keep you awake. So I'm going to talk about, a Java developer's survival guide for the cloud. My name is Syed Shaaf. I'm a technical evangelist. I'm a Java developer. If anybody has used AWT, Swing, Java 1.1? No? Okay. So I've been developing Java for a long time, and I've worked through those different times. And of course, when I look at my experience into how I could move to the cloud and what kind of things I could do, there's many things out there, right? There's the hyperscalers like Google and AWS and Microsoft and whatnot. There's Kubernetes. And of course, this talk is more geared toward Kubernetes. I'm biased since I'm Redhat as well, so a little bit of biased nature is okay, so bear with me. So there's definitely an opinionated talk about some of those things that you would want to consider or look at. And of course, I'm happy to talk further because this topic does not finish in 30 minutes. I hope you guys understand that. But there are things that we could do to go to that journey easier, or the tools that are out there that you could use, right? So that's what I'll talk about. So let's get started. So destination cloud, where are you at? Anybody using Kubernetes? Okay, nice. Or anybody using serverless, Lambdas or something? No hands? One hand? Knative, awesome. So historically, when we're developing Java applications, we have the app server. The whole idea of Java has been to create this vertical sort of stack, right, where you have this app server and you keep on putting your applications inside it, right? And you kind of scale it. You probably had this big machine you could do it with. And it was fine. There was nothing wrong with it. And it was going all fine, right? But then we started thinking about how a distributed architecture would look like. When we start talking about microservices or serverless functions, now here, the state that we were writing in one application now gets shared across multiple instances or multiple services or functions or whatever you want to call it. Historically, of course, when we had big servers, big app servers with a lot of applications on it, what we were thinking of was just stacking up as much and running them as long as possible. Whereas going into the other side, we're looking at, okay, we're looking for smaller lifetime of the application in terms of runtime. It can die and it can recover, et cetera, et cetera. All those different things that come with distributed computing. So the way we used to develop applications on the left side is not the same as it's on the right side. Enter event-driven sort of programming model, and again, you're looking at yourself at consuming those events, reacting to those events, creating, for example, functions that will react to a certain event, do something in a time of some seconds and then die. That's not the way Java developers have developed. Now, I'm sure all of you understand this. I'm just guessing, and kind of have seen some versions of the same talk, same thing that I've been talking about. But of course, the tools, of course, also matter. How do we interact with these systems? What kind of things do we have to ensure that we can develop in the cloud, right? So let's take a look, for example, at runtime. And since I'm at EclipseCon, so a lot of the stuff that I'm going to talk about is the things that are part of the Eclipse Foundation projects, right? So anybody heard about Adoptium this week? Okay, and am I correct to think that all of you are Java developers only? Yeah, okay, cool, awesome. So the Eclipse Adoptium project, of course, is creating the Java, the JVM packages that we need, the distribution for Java. And it does that so with the Adoptium working group, which of course consists of a lot of these different companies like Alibaba, Microsoft, Redhat, and so on and so forth. The idea, of course, is like you have TCK testing, etc. But what about things you need or work with every day? certain frameworks. So what Adoptium is bringing on top of that is making sure that there are some parameters in terms of how the JVM is performing after even the TCK has been passed. So running those tests, for scalability, for security, for functional correctness, like using frameworks specifically that we use in our day-to-day work, right? So that kind of becomes interesting. And of course, Termurin. Who uses Termurin, by the way? Okay, I need more hands up, but anyways. So Eclipse Termurin, I don't know if you know this, but crossed like 500 million downloads, right? If we combine some of the downloads from Adopt OpenJDK, there's 100+ test machines that does this. There's about 350K tests that are written on top of this. So there's a lot of scalability, security that comes into this when you're using in a cloud. Now, why would you do that in a cloud? Of course, you need a secure runtime. So just to put it out there for a Java runtime perspective, if you're using container images, you would use them from Termurin. If you're using Java 19, 18, 16, how many are using Java 19? Okay, I see one hand up. That's pretty okay. Are you using Loom? No? Not yet. Okay. Then, of course, the other runtime that you would see when you're developing microservices is MicroProfile. Anybody here using MicroProfile? Okay, I see a few hands. Awesome. So with MicroProfile, you get a bunch of these different areas where you would look at, okay, how do I have health or observability or telemetry data, for example. So you have that in MicroProfile. How do you write your specific application? What annotations you're using. MicroProfile is giving you all those different segments that you could write a nice, microservices-based application with all the nice annotations that you kind of are familiar with, right? So it's a good framework that you would use. It has other features like reactive streams. Anybody familiar with reactive programming? No? Yes? Okay. Yes and no? That's a good answer. If you say yes and no, I agree. So with reactive programming, of course, what we're looking at is, having, of course, it's performant, it's non-blocking, it has an event loop underneath, and we could have an entire talk on reactive programming, right? So let's just bear with that little introduction for now. MicroProfile also have that kind of area where you can use reactive streams to kind of for example, reactive messaging with Kafka. If you have Kafka, you're getting your events, etc., etc. You have those extensions. If you're using GraphQL, you could use that too. So MicroProfile gives you some of those areas. Another project that is, of course, interesting is the Small Rye project, which is an implementation, of course, for MicroProfile. And it's being used in multiple projects like Quarkus, Wildfly, JBoss CAP. Now, if you're using Wildfly, and let's say you were building your application or maintaining an application for many, many years, if you had to connect to Kafka, what would you do? If you weren't doing event-driven, what would you do, right? So with Small Rye and the reactive implementations into Wildfly, now you can add those extensions in, and you can have reactive messaging with your Wildfly applications or JBoss applications, as an example. So you don't have to just think, oh, I need to use Kafka, and maybe I need to change my stack. No, you can actually start to modernize your application or break your application into smaller pieces as you go forward, and bring some of these technologies to actually enhance that effort as well. So there's some interesting things there too. Jakarta EE, again, if you're using your, if you're familiar with Java applications, you have had them for a while, it's not the end of the road, right? Your Java EE converted into Jakarta EE with, Jakarta EE 10, having the core profile, CDI Lite. I don't know if you have heard about CDI Lite. CDI Lite will enhance your build time process, make your application smaller, and also with a smaller footprint that you can deploy. So 3 options here, right? You have MicroProfile, you have your current systems where you can add things with MicroProfile into it, and then of course, also using Jakarta EE. So if you were having hundreds of applications today running your Java stack, you're not like at the end of the road. There is path for you that you can start to mix and bring in things and strangulate your monolith as an example. Right? So how many are already running Java applications in your stack today? Maybe using an application server. EAP, Wildfly, Tomcat, Glassfish. Yeah, exactly. So there's a path, and of course you can still keep on doing that. Eclipse Vert.x, where comes with the event loop with a non-blocking I/O, which means that everything I'm doing is very close to how asynchronously I'm programming. My mind has to switch a bit, of course, but it is more reactive style programming, ensuring that you can get more out of your system. Now, how does that help? Let's say you have a data source. You query that data source, and that data source takes 60 seconds to come back. That's still a long time, but let's assume. It takes 60 seconds, and under load, it goes up to maybe 90 seconds. Now, what usually would happen is that from your Java code, you're going to request that resource, and then your thread is just waiting for that resource to come back, right? And when it comes back, then you start doing something, which means for 90 seconds, you're just sitting there waiting. Your application or your user is sitting there waiting, right? So with something like reactive, it's going to throw that request into an event loop, and it's going to just fire it and leave it there. And once it's done, it's going to just send it back asynchronously back to your code. So your code can continue, go execute something else, and as soon as it receives that, of course. Now, some of you who use reactive programming might smile at me because it's not something simple. You have to think, you have to wire, and that's what Vert.x, for example, does, is a toolkit that does that. Now, understanding that the reactive programming can be hard, of course, Quarkus also embeds reactive programming inside. So you have reactive APIs or libraries that are like Mutiny as an example, which are much, much more simpler to work with. So enter the world of Quarkus. When we talk about cloud, we talk about how fast you can spin up a resource, right? How much memory is it consuming to do certain things? So imagine a serverless function that takes 10 minutes to boot up. Do you think you can live with that? Is your application going to live with that? A serverless function is supposed to be small. It acts on a particular event. And of course, it does something and dies. Now, if I had to do 100 functions in a matter of even next 30 minutes, and each function took 10 minutes or 5 minutes to load, my application is a sitting duck, right? It's really bad. It's not doing well. So for Java, historically, of course, like I said about the vertical stack, that's how we thought. Things could take time to get up and running, and then, it was okay when they were running, and they would be optimized, etc. But the new world we live in, when we talk about serverless or microservices, we need fast startup times. We cannot do 10 minutes, right? So Quarkus, of course, is a framework that uses GraalVM, but it just doesn't depend on GraalVM itself, but also has a lot of optimizations. So rather than doing all the optimizations after booting up, Quarkus is doing all the optimizations at build time. Well, guess what? Yes, the build time will increase. And that is fine. The build time can increase, but at the same time, it should be able to be quick and fast when it's there. And I'll show you some of that, why and how that happens. When we do a simple REST endpoint, the memory for Quarkus, a Hello World endpoint, we're looking at about 12 megabytes. Now, if you think about any application framework that you use today, and you would do that, that's very small. That's, of course, the native part of it. So what does native mean? Native means it does not have, let's say, a lot of garbage collection algorithms that you would usually see, right? So the whole idea is that it will run, it will do its job, and it's going to die. Quarkus with the JVM mode will have all those possibilities for you to do all those nice things that you're used to, but still has half of the memory that you see in the traditional app on the right side here, right, on this. So still there is a lot of optimization, build-time optimization that actually happens on that level as well. So much easier to use for cloud frameworks. By the way, do you guys like live demos? Somebody said I should do a live demo. So if I have time, I'll do a Quarkus live demo for you as well. But I hope I can finish this. REST, again, when it comes to startup times, you can see native type startup time is in sub-seconds. You have less than a second on the normal JVM mode. And with REST and CRUD, again, you see that startup times are much, much, much better. So again, when you're talking about cloud, when you're talking about serverless functions or microservices, Quarkus is the right fit. This is the way to go. And Quarkus is not the only one doing these optimizations. There are other frameworks out there that are also doing it. So when you write your Java apps today, sure, you can use something like Wildfly. You can use the Jakarta EE, right? You can still have slim versions of your application. You can use MicroProfile, things like reactive messaging, drag them in to your current applications, enhance them even further. You can use reactive programming, but then of course something like Quarkus that does 3 of these different scenarios for you as well. So as a Java developer, you shouldn't feel restricted that I need to change or do something else. Java has all those features enabled for you with those different frameworks. So that's purely the message. What also is important is, and this comes again and again, is how many times do you commit code a day? I can do it maybe 2 or 3 times, and it's not my pure function. And a lot of developers do it a lot more time, right? So when you're developing applications, or I have done it in the past as well, is a rapid testing loop that's going on. You're continuously checking, testing things. They're working, you're running your tests at the same time, and you're creating your new code. And if you were doing that with an app server style programming that we've done in the past, you would need to deploy to your app server every time and restart it, right? And that can take time, and that can be painstaking as well, right? So development velocity is important. So if I call this particular place where I am creating code, testing it, and then committing it, for example, the inner loop of my development, right? So I'm continuously changing things, making sure I can work with this is the inner loop. If in the inner loop I have to keep on going and dragging things outside and deploying things outside and not having enough fast time, it's going to increase the amount of time that I take to code every day. So one of the things that is important is how do we ensure that our inner loop is faster, right? So again, in terms of development loop, whether we are doing it internally or writing it to different, but I certainly sometimes have multiple branches that I need to pull, right? Or if it's their PRs, I need to pull them and see how they're working, and all of that, I need to kind of test it sometimes and even make changes to it. So that's the life that we live in. How do we make it faster? With Quarkus, some of the things that we've done is, and one of the primary aspects of Quarkus is developer productivity or developer joy. With developer joy, of course, what we're looking at is, all the configuration that you're doing, how to make it more simpler. Live coding, so while you're coding, you can change everything and it keeps on working the way it does, right? And then, of course, there are other areas, continuous testing as an example. So maybe I'm going to be very optimistic, and I'm going to try to demo this. So I spoke about developer productivity, and I just wanted to showcase, because these are not the things you can do on a slide. Okay? There you go. Perfect. Let's see if that works. So here what I've done is basically I've created a Quarkus project already. There is a talk that's going to go in a lot more detail. I would have just created the project. Usually I would go on something like code.quarkus.io. So code.quarkus.io. If it comes up, come on. Okay, yeah, there you go. Though of course I'm having some network issues. Perfect. So all the different extensions are listed here, whether they're reactive, etc. I would generate a project, and once I generate the project, I can download it, blah, 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 and it's going to come out there, right? So what I've done is I've basically taken the same project, I've added some things to it. But at the same time, I have a greeting resource, right? Simple greeting resource. What I would do is, in my project, I can do mvn Quarkus dev. This is what's called the dev mode. Now, why is this important? I'll show you in a second. This is going to spin up my application, a Quarkus application, and you can see that it's also pulling a container out. Here you'll see that it's also making an SQL container. So if I go here now on my Docker containers, I will see that a new container has been provisioned. What does this mean? This means basically is that in my dependencies, I have said that I'm going to be using something as simple as the Hibernate extension for Quarkus. When I'm using this Hibernate extension, it will automatically create containers in the backend, and it will work with that. So I have a container here. If I stop my application now, and I go back, the container is gone, right? So what it's doing is, if I add Kafka, or if I add Debezium, some of these other tools, as soon as I add them into my application, automatically it's going to spin up the containers in the backend. Now, how is that beneficial for me? Let's take a look at that too. So I'm going to run this again, of course, and the whole idea of Quarkus dev is that you should never be able to run it, rerun it. I've just sort of killed it to show you that it's not a container already running. So now again, you can see that the container, a new container has been provisioned. If I go on my Quarkus console, which is my localhost 8080, and we have something called the dev UI. The dev UI, of course, gives me all these details, but then if I go into my config editor, all the different configurations I have, if I write Postgres here, so here you can see I have a Postgres data source, and it's basically connecting to that container automatically. Of course, I'm not going to do this in production, so there are different profiles that I would use. So there's a lot of things here, but let's for the nicety of this time that I have, see what we can do. So let's say, what's my app? Going back here, to do HTML is the app that I've created. Simple app, you see that I add something here, the tasks are here, I can kill it, etc., etc. What does live coding do for me? I'm just going to cheat a bit here. I'm going to, since I do this all the time, as you can see, so much practice, I'm going to take the import SQL file, which is this one. I'm going to drag it into my resources here, right? And as I do that, I don't need to restart. Quarkus is still running. I hit my URL again, and all the things that you saw in the import SQL are here, right? So this is simple, all the configuration. If I add a Maven extension right now, a Maven POM into my POM file, a new dependency, it will automatically get loaded as well. I do not need to restart. Perfect. So if I go here and start changing code, for example, I did this. Why would I do that? But let's just do it. I get an error. I get a reverse stack. So in Java, as you know, and most of the frameworks, you have to scroll down all the way to the stack. Here, you get the reverse stack, so you get the error directly, right? So stuff like that, that kind of keeps on helping me to do that. Not just that, I can also start to do continuous testing. So I can test my code by pressing R over here. I can run my test. Perfect, my test is running. But then I go back and say, hey, my greeting resource, let's change the endpoint. Whoa. I hate Mac. Oops, that got recorded, sorry. I save this, and here you see there's a test failure right away. So while I'm actually coding, I'm writing my tests. If you're a test-driven development person, You keep on writing your test, keep on writing your code, keep on adding Quarkus extensions. All of these things, they're happening. There are containers being provisioned at the back, and it's easier and simpler, right, to do it. If I change my endpoints will change as well. So all of this is dynamic, no restarting needed. Definitely the velocity, the way you work, the speed of your work is enhanced. Does that make sense at all? Okay, I hope I didn't confuse you with this. So I'm gonna just kill this, go back to my beautiful slides. Let's see where we were. Okay, perfect. So I changed the mic, guys. It's always good to visualize something, right? Before I go on my next 300 slides and make you guys sleep. Anyway, so what we saw is that the configuration is simple. You can code, live code, you can make changes, you keep on doing that. Also, there's a cool feature in this. I didn't show it. You can actually deploy directly to Kubernetes with the Kubernetes extension. But you can also do remote dev, which means that I could actually keep on coding on my machine, but it will be running, the application would be running in a container inside Kubernetes, right? So for that, maybe you can come to the booth and we can try it out and show you there, right? So it gives you these features to do faster development. Definitely enhances the loop, right? What you also saw, of course, was things like, we call dev services. If you're using simple things like MongoDB or Redis, it will also do, container provisioning for you in the backend. Kafka, anybody uses Kafka? So yeah, so if you're using streams, it will do your live stream processing as well. So as you change your code, it's going to process those streams as you're changing the code, so you don't need to restart it. It also has the possibility for you to go inside and read the topics as well, right? So a lot of stuff in there that helps you to do that. I already showed this in the demo to you, sort of, but here you also see something with %prod. And that is modulus prod is a profile. The profile is saying that, hey, there's a database source on line 33 when you're in production, but there is no database source in your development because it's actually using test containers in the backend, as an example, right? So some cool things there. Let's move on to security. When you're developing your applications in the cloud and you're using microservices or you're having functions, you want to communicate. You probably use JWT tokens or something similar, or you even have applications that are using, things before. So with something like Keycloak project, anybody familiar with the Keycloak project? Awesome, nice. It's one of my favorite projects. It gives you all the possibility to connect between these different, features. Like, for example, if you're running Active Directory, want to connect with ADFS, stuff like that, or you're using, third-party social logins, OpenID Connect, SAML v2, all of those things. So it will enable you. So let's say you have a multi-cloud solution and you're running an application in AWS and you're running an application in Azure. How do you secure it today? Right? I mean, you need to have the simple way to secure it. You use something like Keycloak to do it, right? So that will basically be between the two clouds as well. And it's not dependent on a single solution. So stuff like that is going to help you. And of course, there's HR and all those things we can't discuss in this talk. But yes, you can do that. When we talk about security, we should also talk about supply chain. And of course, in supply chain, what you want to do is make sure that you're moving all your configurations and your code into more area where you have infrastructure as your code as well. But not just that, ensuring that you're using tools like CSPM to make sure you have protection, how you're executing, you need to isolate those environments, right? But first, what you need to do, of course, is perhaps have a chain of how you're going to do this. So with Quarkus, you have the dev mode, for example. You do your unit testing, quality code, but then, of course, what about your images? Do you do image scans of your deployments, the builds that you do? Do you do deployment checks, deployment scans? So you need to have tools where you can actually ensure that, hey, when I have enforcement or policy on, I know that, okay, these are the different CVEs that are violating in my particular image at this moment when this application is running. There are definite solutions for that, right? And then, of course, be able to fix them and see, okay, when they go into, for example, deployment, do I have these certain rules that can be deployed as well in based off my images? And of course, something with Red Hat OpenShift, you have that security possibility as well. Something also close to me is observability. So when we talk about observability, it's not just about metrics and alerts and all these different pieces, because historically in Java applications, we use JMX, we get that data out of the system. And of course, what we want to make sure is when we go in a distributed style, a serverless function is running or microservice is running, it ran, what did it do? What did we get out of it? If we just got the logs, can we make sense of the logs? But I think the most important thing is like, what is the user journey? What is the request journey that is happening? How do you correlate that request journey across this distributed environment? So there's definitely tools to do that too, and you need to ensure that you're not just doing logs and alerts, but you're actually also doing tracing. So with OpenTelemetry, now you can do auto tracing as well, so you don't need to create all those spans. It's going to do it for you, as an example. So that's a nice tool that will enable you in whether you're using Wildfly, whether you're using Quarkus, whether you're using Spring, all those different frameworks, it's going to help you do that too. Finally, another lesson, of course, is the GitOps part. So making sure that when I'm writing my Ansible playbooks, of course, how many familiar with Ansible? Okay, nice. And of course, when you're writing your Ansible playbooks, that they are also going into the code element that you have, right? So ensure that you're treating everything as code, you're auditing it, you're making sure that whenever you're making changes, you're actually making changes across the board and not just to your applications as well. Possibility to do something like drift checking, so able to see what's the difference between these two different branches that we did or these two different commits that we worked with, kind of also gets important when you start doing that as well. So here's just an example. Of course, I don't expect that everybody's pipelines are going to be like this, but of course, with everything that I've showed so far, you're looking at not just CI/CD, but you're also looking at the different tools and execution. Like I said, enforcement of checking your images, scanning your images, signing your images, right? And also making sure that all the CVEs, et cetera, are there to manage that life cycle between those different areas as well. So I think I just kind of rammed through these slides a bit. I'm happy to talk again later if you want to come by the booth. There's a bunch of talks that we're doing. This one in the corner, I think you should definitely go if you want to learn more about exactly how Quarkus is working, how the developer mode is working, how you're developing applications. So Martin is going to go in a lot more detail than I have, right? Not a 5-minute demo, but definitely a longer demo. And some things here for getting started, but you will have the slides after the session. So I think I'll take a pause and, wow, I'm on time. So any questions? Yeah.
Question about Quarkus. Are there any plans to support Jakarta E?
Any plans to support Jakarta E? There is some compatibility over there. There is definitely discussion about it. I cannot say whether there's concrete evidence to say, but there is already some compatibility in Quarkus with Jakarta E. Yeah. A yes and no answer. Okay. Perfect. If there's no other questions, thank you so much. And I'll be at the Red Hat booth. If you drop by, get a t-shirt, and we can have a chat. Thanks.